Britain emerged from World War II victorious, but economically exhausted, facing the challenge of maintaining military capabilities adequate for a global empire in decline, while managing severe financial constraints and the transition from wartime to peacetime economy. The story of British tanks in the post-World War II era is one of innovative design often hampered by limited budgets, excellent engineering compromised by changing requirements, and the gradual recognition that Britain could no longer afford to develop and produce entirely indigenous tank designs for a shrinking army. From the Centurion that proved to be one of history's most successful tank designs, to the Chieftain that established new standards for firepower and protection, from the troubled development programs that produced few or no service vehicles, to the eventual adoption of the Challenger series that represented Britain's last indigenous main battle tanks, British armor evolved through successive generations while navigating the empire's dissolution, Cold War requirements, and the realities of reduced defense spending. Britain's unique approach to tank design, emphasizing firepower and protection over mobility, reflected lessons from World War II and the defensive orientation of British Cold War strategy as part of NATO's northern flank in Germany. The British Army of the Rhine, stationed in West Germany as part of NATO forces facing the Warsaw Pact, required tanks capable of engaging superior numbers of Soviet armor in defensive operations, leading to designs that prioritize killing enemy tanks over offensive maneuver. Throughout the Cold War, British tanks saw combat in various colonial conflicts, brushfire wars, and peacekeeping operations from Korea to the Falklands, providing combat experience that informed continuous development while demonstrating both the strengths and limitations of British designs. The eventual decision to collaborate with other nations on tank development, culminating in programs like the failed MBT-80 and ultimately leading to closer cooperation with American armor programs, reflected the economic realities of late 20th century defense procurement. This comprehensive examination explores every major British tank from 1945 through the present day, revealing how British armor evolved from World War II, designs through the Centurion's remarkable success, the Chieftain's innovations and problems, to the Challenger series and ultimately the decision to adopt American Abrams technology, tracing Britain's journey from independent tank power to junior partner in international programs. Immediate post-war period, cruiser and infantry tanks. Comet cruiser tank, a 34. The Comet cruiser tank, while designed during World War II and entering service in late 1944, became Britain's primary tank in the immediate post-war years and remained in service well into the 1950s. The Comet represented the culmination of British cruiser tank development, finally achieving a balanced design that combined adequate firepower, good armor, excellent mobility, and reliable mechanics. Weighing approximately 36 tons with armor up to 101 millimeters on frontal surfaces, the Comet was well protected by 1945 standards, though increasingly vulnerable as anti-tank weapons improved. The 77mm HV gun, essentially a shortened 17-pounder firing different ammunition, could defeat any contemporary armor at typical combat ranges. The Rolls-Royce Meteor engine, producing 600 horsepower, gave maximum speed of 47 kilometers per hour with excellent cross-country mobility. After World War II ended, Comet tanks equipped British armored regiments in the British Army of the Rhine in Germany, territorial army units in Britain, and overseas garrisons. The tank's combination of firepower, mobility, and reliability made it effective for post-war occupation duties and training. Comets remained in British frontline service until the mid-1950s, when Centurions became available in sufficient numbers to replace them. Even after withdrawal from British service, Comets were sold to various nations, including South Africa, where they served into the 1970s. The Comet's successful design demonstrated that British engineers could produce excellent tanks when given adequate time and resources, though by 1945 the basic design was reaching the limits of its development potential. Churchill infantry tank, Mark 7. The Churchill infantry tank, particularly the Mark 7 variant with 75mm gun and heavy armor, remained in British service through the immediate post-war period in various specialized roles. While the Churchill's slow speed and World War II-era design made it obsolete as a main battle tank, its heavy armor and excellent obstacle crossing ability ensured continued utility. Churchill tanks equipped the Royal Armoured Corps School for training, with some continuing in service into the 1950s. More importantly, Churchill chassis formed the basis for numerous specialized armored vehicles, including AVRE, Armored Vehicle Royal Engineers, variants that continued serving into the 1960s. The Churchill's reliable mechanics and proven chassis made it suitable for engineering vehicles, bridge layers, and other support roles long after it was obsolete as a gun tank. Centurion Universal Tank, Mark I to III early production. The Centurion Universal Tank, which would become one of history's most successful tank designs, appeared in prototype form in 1945, with the first production vehicles delivered too late to see World War II combat. However, development continued, and Centurion became Britain's primary post-war tank development. Early Centurion Mark I and Mark II featured the 17-pounder gun and various teething problems that required correction. The Mark III, entering service in 1948, incorporated improvements including the 20-pounder gun and better reliability that established Centurion as a viable combat vehicle. We will explore Centurion's full story in its own section, as it dominated British armor for decades. The Centurion era, Britain's most successful tank. Centurion Mark III and early variants. The Centurion Mark III established the pattern for what would become Britain's standard tank for over 2 decades and one of the Cold War's most important armored vehicles. Entering service in 1948, the Centurion Mark III weighed approximately 51 tons, with armor up to 152 millimeters on the frontal turret, providing excellent protection for its era. The 20-pounder, 83.4 millimeters, gun represented a significant advance in British tank armament, offering better penetration than the 17-pounder and firing improved ammunition. A coaxial machine gun and later a ranging machine gun supplemented the main armament. The 4-man crew of commander, gunner, loader, and driver operated in relatively spacious conditions with good ergonomics. The Rolls-Royce Meteor engine, producing 650 horsepower, gave maximum speed of approximately 35 kilometers per hour, slow compared to some contemporary tanks, but adequate for the Centurion's defensive role. The Horseman's suspension provided excellent cross-country mobility and the ability to engage targets while moving. Centurion Mark III tanks equipped British armored regiments in Germany, forming the core of British armor facing potential Soviet invasion. The tank's heavy armor and powerful gun made it well-suited for defensive operations in German terrain. British Centurions saw their first combat in the Korean War, where the tank's armor proved nearly impervious to North Korean and Chinese anti-tank weapons, while the 20-pounder devastated enemy armor and fortifications. The Centurion's performance in Korea enhanced its reputation and led to export orders. Centurion Mark V, VI, and VII. Continuous improvement. The Centurion underwent continuous development through numerous marks, each incorporating improvements and modifications. The Mark V introduced a new mantelet design and improved gun stabilization, allowing more accurate fire on the move. The Mark VI and VII incorporated additional improvements to armor, mechanics, and systems. British industry produced these upgraded variants while also refurbishing older Centurions to later standards, creating a fleet of modernized tanks. The Centurion's basic soundness of design allowed it to absorb these improvements while maintaining reliability and combat effectiveness. Centurion Mark VIII, IX, and X. The 105mm gun. The introduction of the L7 105mm rifled gun represented the most significant Centurion improvement, transforming firepower and ensuring the design's continued viability into the 1960s and beyond. The Royal Ordnance L7 105mm gun, developed in response to Soviet heavy tank development, could penetrate over 300 millimeters of armor at 1,000 meters with APDS ammunition, making it effective against any contemporary armor. The Centurion Mark VIII introduced the 105mm gun in 1955, with the Mark IX and Mark X featuring additional improvements, including infrared night vision equipment, improved fire control, and better armor. British Centurion Mark VIII, IX, and X tanks equipped the British Army of the Rhine through the 1960s and into the 1970s, providing NATO with capable tanks despite the design's increasing age. The 105mm gun's effectiveness ensured Centurions remained competitive even as newer Soviet tanks appeared. British Centurions saw limited combat in various colonial conflicts and peacekeeping operations, though major tank versus tank combat fortunately never occurred. The tank's reliability and firepower made it valued by crews despite its slow speed and aging systems. Interim designs and failed programs. Conqueror Heavy Tank. The Conqueror Heavy Tank was developed in the early 1950s specifically to counter Soviet heavy tanks like the IS-3 and T-10, mounting the powerful 120mm gun in a heavily armored hull and turret. Entering service in 1955, the Conqueror weighed approximately 66 tons, with armor up to 178mm on frontal surfaces, making it one of the most heavily armored British tanks ever produced. The 120mm L1 gun could penetrate any contemporary armor at long range, giving British armored regiments a weapon capable of defeating Soviet heavy tanks. Two 7.62mm machine guns supplemented the main gun. The four-man crew operated in cramped conditions due to the large gun and ammunition storage requirements. The Rolls-Royce Meteor engine, producing 810 horsepower, struggled with the Conqueror's massive weight, resulting in maximum speed of only 34 kilometers per hour and chronic mechanical problems. The Conqueror equipped heavy tank troops in British armored regiments in Germany, with 2 or 3 Conquerors supporting troops of Centurions. However, the tanks suffered from serious reliability issues, with the engine, transmission, and suspension proving troublesome. Maintenance requirements were excessive, and the Conqueror earned a poor reputation for mechanical problems. British Conqueror tanks never saw combat, serving solely as deterrent against Soviet heavy tanks. By the early 1960s, improvements to the Centurion's 105mm gun and the development of improved ammunition made the Conqueror's specialized heavy tank role unnecessary, as Centurions could now defeat Soviet armor at adequate ranges. The Conqueror was withdrawn from service by 1966, with only about 185 produced, making it one of Britain's least successful post-war tank programs. The Conqueror represented an expensive dead end, consuming resources while providing limited operational value due to its mechanical unreliability and the questionable need for a specialized heavy tank. FV-4401, contentious. The abandoned tank. The FV-4401. Contentious was a proposed light tank design intended to provide reconnaissance capability and support for airborne forces. Development began in the late 1940s, but the program was eventually abandoned without entering production, as Britain decided to focus resources on main battle tanks like Centurion rather than specialized light tanks. The Contentious exists primarily as a footnote in British tank development history, representing one of many projects that consumed design resources without producing service vehicles. Chieftain Mark I through Mark V, early production. Early Chieftain production models, Mark I through Mark V, suffered from chronic engine problems that plagued the design throughout its life. The Chieftain weighed approximately 55 tons with advanced composite armor, providing protection superior to conventional armor of equivalent weight. The glacis plate used composite construction incorporating layers of different materials, creating protection against both kinetic energy and chemical energy weapons. The 120mm L11 rifled gun-firing APDS and later APFSDS ammunition could penetrate over 400 millimeters of armor at 2,000 meters, making it the most powerful tank gun in Western service when introduced. A coaxial 7.62mm machine gun and Commander's 7.62mm machine gun supplemented the main gun. The ranging machine gun mounted alongside the main gun fired bursts of 12.7mm ammunition for range finding before laser rangefinders became standard. The four-man crew consisted of commander, gunner, loader, and driver, with the driver positioned in a reclining seat allowing a hull height reduction. The Leyland L60 multi-fuel engine was designed to produce 750 horsepower, but suffered chronic reliability problems, frequently producing less power than specified and breaking down. The Horseman suspension, similar to Centurion's design, provided adequate ride quality. Maximum design speed was 48 kilometers per hour. though actual performance was often less due to engine problems. British Chieftain Mark 1-5 equipped armored regiments in Germany starting in 1967, replacing Centurions. However, the engine problems created serious operational issues, with Chieftains frequently broken down and unavailable for operations. Maintenance requirements were excessive, and crews lost confidence in the vehicle's reliability. Chieftain Mark 6 through Mark 10 improved variants. Later Chieftain production, Mark 6 through Mark 10, incorporated progressive improvements attempting to address engine problems and improve reliability. Modifications included improved engine components, better cooling systems, upgraded transmissions, and various mechanical improvements. The Mark 7 and later variants received improved fire control systems, including laser rangefinders replacing the ranging machine gun, ballistic computers, and thermal imaging sights for night combat. These improvements enhanced combat effectiveness significantly. The Mark 10, entering service in the late 1970s, represented the definitive British Chieftain with the most improvements and better reliability than early models, though engine problems never fully disappeared. British Chieftain Mark 6-10 equipped the British Army of the Rhine through the 1970s and 1980s, providing NATO with heavily armed and well-protected tanks despite the mobility limitations. The 120mm gun's power and the composite armor's protection made Chieftains formidable defensive weapons. Chieftains saw combat in the 1991 Gulf War in limited numbers with British forces, though by then the tank was being replaced by Challenger 1. The Chieftain's combat employment in a major conflict finally occurred after decades of Cold War deterrence. The Challenger era, modern main battle tanks. Challenger 1 main battle tank. The Challenger 1 main battle tank was developed rapidly in the late 1970s and early 1980s as an emergency program to provide a Chieftain replacement after MBT-80 cancellation. Based partially on Iran. Chieftain development for Iran, Challenger 1 incorporated advanced composite Chobham armor, improved fire control, and attempted to address Chieftain's engine problems. Challenger 1 entered service in 1983, weighing approximately 62 tons, with revolutionary Chobham composite armor providing exceptional protection against both kinetic energy and chemical energy weapons. The exact composition remained classified, but the layered construction incorporating ceramics and other materials created protection far superior to equivalent thickness of steel armor. The 120mm L11 rifled gun, same as Chieftain's weapon, provided proven firepower, though increasingly challenged by more modern 120mm smoothbore guns. Advanced fire control systems, including laser rangefinder, ballistic computer, and thermal imaging sights provided excellent accuracy. A coaxial 7.62mm machine gun and Commander's 7.62mm machine gun supplemented the main gun. The four-man crew operated in improved conditions compared to Chieftain. The Rolls-Royce CV-12 diesel engine, producing 1,200 horsepower, finally provided adequate power for a British heavy tank, giving maximum speed of 60 kilometers per hour and much better reliability than Chieftain's troubled engine. The Hydrogas suspension, replacing Chieftain's Horseman design, provided excellent ride quality and cross-country performance. Challenger 1 equipped British armored regiments from 1983 through the 1990s, replacing Chieftains and providing NATO with modern main battle tanks. The Chobham armor's protection and improved mobility represented significant advances over Chieftain. Challenger 1 tanks saw combat in the 1991 Gulf War, where they proved devastatingly effective. British Challengers destroyed numerous Iraqi T-55, T-62, and T-72 tanks at long range, with the L-11 gun and advanced fire control allowing engagement and destruction before Iraqi tanks could respond. Challenger 1 achieved one of the longest-range tank-on-tank kills in history when a Challenger destroyed an Iraqi tank at approximately 5,100 meters. The Gulf War validated Challenger 1's design, demonstrating that British armor could perform superbly in combat. However, Challenger 1 never achieved significant export success, with only Jordan purchasing the type. Approximately 420 Challenger 1 tanks were built, all for British service except the Jordan sale. The limited production reflected both the tank's late introduction and Britain's shrinking defense budget in the post-Cold War era. Challenger 2 Main Battle Tank. Challenger 2 main battle tank development began in the late 1980s to provide an improved Challenger, incorporating lessons from Challenger 1 service and the latest technology. Entering service in 1998, Challenger 2 represented Britain's final indigenous main battle tank design and remains in service today. Challenger 2 weighs approximately 63 to 69 tons, depending on configuration, with second-generation Chobham armor providing exceptional protection enhanced by add-on armor packages. The 120mm L30 rifled gun, developed specifically for Challenger 2, offers improved performance over the L11, including better accuracy and penetration with modern ammunition. Britain's decision to retain a rifled gun rather than adopting smoothbore technology used by other nations reflected confidence in rifled gun performance with modern ammunition, though it creates ammunition compatibility issues with allies using smoothbore weapons. Advanced fire control systems, including hunter-killer capability, allowing commander and gunner to engage separate targets. Thermal imaging, laser rangefinder, and ballistic computer provide world-class accuracy. Coaxial 7.62mm chain gun and Loader's 7.62mm machine gun supplement the main gun. The four-man crew operates in the most advanced British tank to date. The Perkins CVI 12-6, a diesel engine producing 1,200 horsepower, provides adequate performance with maximum speed of 59 kilometers per hour. The hydrogas suspension provides excellent cross-country mobility. Challenger 2 equipped British armored regiments from 1998 onward, replacing Challenger 1 and providing Britain with modern main battle tanks for the 21st century. The tank saw combat in the 2003 Iraq War, where Challenger 2s performed well, though facing less sophisticated opposition than in 1991. One Challenger 2 was hit by over 70 RPG rounds and survived, demonstrating armor effectiveness. Approximately 446 Challenger 2 tanks were produced, all for British service except Oman, which purchased 38. The limited production and lack of export success reflected post-Cold War British military contraction and the lack of major tank procurement by most nations in the 1990s and 2000s. FV-101 Scorpion Light Tank. The FV-101 Scorpion Combat Vehicle Reconnaissance, tracked, entered service in 1973 as part of the CVR-T family, providing British forces with fast, light armored reconnaissance. Weighing only 8 tons, the Scorpion featured aluminum armor, providing protection against small arms and shell fragments, but vulnerable to anti-tank weapons. The 76mm L23 gun provided firepower superior to machine guns, capable of engaging light armor and infantry. The 3-man crew operated this air-transportable vehicle. The Jaguar 4.2-liter petrol engine, producing 190 horsepower, gave maximum speed of 80 kilometers per hour, making Scorpion one of the fastest tracked vehicles in service. Scorpions equipped British reconnaissance units from the 1970s through the 1990s and saw combat in the Falklands War, where their mobility and firepower proved valuable. Numerous nations purchased Scorpions, with the type seeing service worldwide. British tanks after World War II represent a story of innovation often compromised by limited budgets, excellent engineering sometimes undermined by reliability problems, and the gradual recognition that Britain could no longer afford independent tank development as a small island nation with diminishing global commitments. From the Centurion that proved to be one of history's finest tanks to the troubled Chieftain that combined superb firepower and protection with chronic engine problems, British armor evolved through successive generations while navigating economic constraints and changing strategic requirements. The Centurion's remarkable success demonstrated that British designers could create world-class tanks when given adequate resources and time. The 4,400 Centurions produced equipped British and Allied forces for decades, saw combat in multiple conflicts, and established reputations for reliability and effectiveness that made it one of the Cold War's most important armored vehicles. The Chieftain represented British design philosophy taken to extremes, emphasizing firepower and protection while accepting reduced mobility. The powerful 120mm gun and advanced composite armor made Chieftain formidable, but chronic engine problems prevented the tank from achieving its full potential, and tarnished its reputation, despite eventually achieving some export success. The Challenger series finally provided Britain with truly modern main battle tanks, though late introduction and limited production reflected post-Cold War military contraction. Challenger 1's Gulf War performance and Challenger 2's capabilities demonstrate British ability to produce competitive modern armor, even as questions about future affordability persist. Throughout the post-war era, British tanks served primarily as Cold War deterrent, facing potential Soviet invasion that fortunately never materialized. The combat experience in Korea, the Falklands, and the Gulf Wars provided validation of design concepts and demonstrated that British tanks could perform effectively when called upon. Today, Britain maintains a small but capable armored force with Challenger 2 tanks, though the future remains uncertain as defense budgets shrink and questions arise about affordability of maintaining indigenous tank capability. The Challenger 3 upgrade program represents Britain's current commitment to armor, though whether it represents the last indigenous British tank or a foundation for future development remains to be seen. When we remember British tanks after World War II, we should remember the Centurion crews fighting in Korea, the Chieftain tankers maintaining readiness in Germany during the Cold War, and the Challenger crews achieving remarkable success in the Gulf Wars. The tanks they operated, from Centurions to Challengers, represent Britain's determination to maintain armored capability despite economic constraints and the evolution from global power to European nation navigating the complexities of modern defense in an uncertain world.